Hi guys, this is Nate from Reach 3D Printers here. This video is a jam video. We're going to see what happens and how to fix a jam and all the different possibilities that can occur. I'm going to try to cover them all. There are a lot. Things aren't perfect. It can definitely be a major headache. So real quick, what I've set up is an intentional failed print. As you can see, one of the worst things you can do is have the fan blow in the wrong direction. So that's sticker facing out is not good. It's also not blowing on the heat sink. The heat sink is rather hot to the touch. I'm attempting to create a clog up top, and on top of that I increased the temp up to 220 for PLA, which is pretty darn warm, in hopes of creating that clog up there without cooling. That would then hopefully the clog will hold back the filament and create a jam, and this gear will hopefully strip the filament on the inside. So as you can see, it looks like we're pretty much jammed at this point. It almost got it there, but it kept going, so I upped the temperature over here. So here we go. We're gonna say that this is currently a failed print, and we're gonna go ahead and clear this clog, and I'll show you all the steps, how to dismantle it and what to look out for. Alright, we'll be right back. Alright guys, first thing to do is to attempt a push-pull to get the filament flowing. So we're going to go ahead and going to stop the print if you are there. If the print's finished, it's finished. Either way. We're also going to disable steppers. Now keep in mind, we just stopped the print. We didn't turn off the heat. The heat should still be on. Double check that info screen. We got 221 as our 220 is our current temp. So going to prepare, preheat PLA 1. That's going to reset it down to 205. So we're putting it at 205. Now what we're going to do is attempt a push-pull. A push-pull is basically taking the filament, sending it through manually, and seeing if maybe there's something wrong with the motor. Now I can feel it stripped right there. You turn this gear and you hold on to that filament. It just kind of sits there and grinds. So either this is too tight or whatever. So what we're going to try to do is try to rotate this backwards and try to pull it out. And often you can get that to release in there, and I can hear it up in here going. So I think I did get it to pull up and out the jam that I was attempting to create down there. But let's say you can't get it to. Well, if you attempt to push it on through, so this time I'm sending it forward, rotating the gear and pushing the filament, trying to get anything to come out of the nozzle, and it doesn't look like it's going to go. Keep in mind I'm still at 205. Alright, so let's say we're stuck there. Now what do we do? Well, the next thing we need to do is to determine if the jam is in the hot end or if it is in the extruder assembly. And actually we have one in both at this point. So we're going to split the two apart. How we're going to do that is you're going to push this blue collar down, and then you're going to rotate the large gear. Well, that won't work because we have to do it right here. So the idea is that we can get the jam to release and squeeze out the tube either here. This is probably the easiest place. You push in the blue collar and rotate this. See how the filament just pushed out the white tube, and out it comes. Alright, so now we've got the two separated. This should be easy to remove here. So push in the blue, press in the filament tube, lift the filament tube back out. Okay, so now we've got this pulled out. The filament's still connected. There's plenty of room here for the filament to travel. And then I'm going to cut the filament right there. Okay, so these two are separated. We got the hot end, still hot, and we got the extruder. The first thing we're going to do is, oh, look at that. See how I can just pull that through? So these are not tight enough. See how, okay, now I'm starting to pull it. Nope, still not tight enough. If I can hold the gear and push the filament, that's bad. So these need to be much tighter. So you can tighten these up. M3 nuts, or M3 bolts. Okay, that's pretty tight. So when I pull on it, gears actually move, but I can still compress it with my fingers and slide it. So that's about right as far as tension goes. And you may want to check the back of this and see how deep the bolts are. Alright, moving on. So we're going to say that maybe that was the cause, but we're going to go ahead and continue our breakdown. Part of that is to check into the extruder. So next thing we're going to, if it did feel smooth, well, I'm going to get into another part first. If you could send this through and it felt smooth, then you're probably okay to go on with dismantling the heater. We're going to break this fully down first. We're going to open the arm by pulling those two bolts out. Don't lose your M3 nuts back here. We're going to check in here for debris. You go ahead and pull your filament all the way out. Unfortunately, you do lose some filament. Anything that's damaged from the gear, you can feel gear teeth on it. Break it off where the gear teeth are. Okay. Make sure that doesn't unravel. You can also have a twist in your line. If this gets cross-threaded, because you got underneath the previous loop, it can bind and create a knot. Like, it can tighten as it rolls out and cause resistance where it can't feed. Clear out the gear in here. Make sure that's nice and clean. Make sure your bearing here, your idler bearing, is smooth and runs free. And if everything feels correct there, and when you turn this, your motor turns, then you can reassemble, which could be difficult. There we go. If you just get it threaded, usually it just catches. Alright. Okay. So that's the extruder. One thing we want to test before we are finished with the extruder is we want to take some filament, send it on through. As soon as I see it come through the black tube, I can see I can't compress that very easily, so I'm going to loosen this up a tiny bit. Just a turn. It's a lot better. Now while I'm squeezing these together, I'm pushing the filament as straight as I can. I should start to see it come out of the top about right now. Okay, so that feels pretty smooth to me. So if I compress this and move this back and forth, it feels good. I don't feel like there's any issues there. So if this is feeding smoothly, then we can test the motor, see if the motor will turn and push this material out, the PLA out. Prepare, move axis, 1 millimeter, extruder. Now your extruder has to be, your temperature has to be up for this to function. Yep, so motor's turning, everything's turning. If that doesn't turn, then it could be a wire problem. It could be this nut isn't touching that motor shaft. It could be the stepper driver needs replaced. But if that does turn, then we've just eliminated this entire side from being the problem. You still have the potential of this not being tight, properly tensioned, but we'll get to that maybe a little further at the end. Okay, so let's work on Hotend now. That's step 2. Alright guys, we're back. We are ready for step 2 of the jam video. We are going to start working on the Hotend because we've basically concluded that the extruder system and the tube, there's no kinks or issues there. We believe the kinks are happening here. Now, a quick test before you break this down is you can take this and kind of push it and pull it. And if it's hot, you should either be able to pull this out without a whole lot of difficulty or push this in and see material coming out. So if that's the case and you can't push or pull this, then this extruder area may be okay and you may not have to mess with that. So now we know for a fact that the problem's here. So what we're going to do is we're going to start by pulling off the brass coupling while it's hot. So when we pull off this brass coupling, I can actually feel it's actually warm. Hopefully you've checked the fan is facing backwards, because right now I got heat up in here. Those fins are actually somewhat warm, which is not good. But we can pull the brass coupling. You can look through it and verify that there's nothing in there. There's no little teeth kind of grabbing that are damaged. Boom, look at that. Look at that, guys. I'm not sure if you can see that. Yeah. Somewhere. There we go. Okay. So that's a horrible coiled up clog of material. So this is clearly the jam. There may be one further down. I don't know for a fact. How we can determine that, toss that guy away. Get a scrap piece of filament. And you can quickly determine if that's the only issue. Look at that. So we got flow coming through here. So it seems like, well, it's fixed, right? We got no other problems. This guy is, if this is feeding smoothly and this is pushing smoothly through here, then we should be fine. But it's going to happen again, obviously, because we have fixed the symptom, not the problem. So there's things that you still got to check. Just because you unclog it doesn't mean, you know, you've necessarily fixed the problem. All right, moving on. The step 2 would be if you still can't find out, well, let's say it didn't pull out and it's still further jammed and we can't send anything else through, then your next step is going to be to dismantle the hot end area. If it did send through, well, that's pretty good news, but you still need to figure out what's going on. So, for instance, I know it's the fan and the temperature set to 220 instead of around 200. So the next step is to dismantle it. Now, before you start taking everything apart, it's very important to note this white thermistor wire, it must remain in the block. Otherwise, you can get thermal runaway. It's super, super important. If that thermistor comes out and is kind of hanging off to the side, it's going to kick this heater on and try to heat it up because the thermistor's reading it's too cold. Well, it can be like 300, 400, 500 degrees on that block, and the thermistor's reading 180. And that's called thermal runaway, and it can literally start a fire. So you guys got to be really careful with that. All right, to continue, we're going to turn the temperature down to about 140. So go to prepare. I'm sorry, that's not correct. Go to control, temperature, nozzle, and take that nozzle down to 140, 150, something like that. 143, that's what I landed on. Okay, so now we're going to pull these bolts. You try to. All right. There we go. Or pull the nuts. Get this guy off here. Get the fan. Okay, now keep in mind this is still 140 degrees, so be very cautious. It's alright, just the fan. Alright, so we pulled this guy out, and the purpose behind pulling him is because we need to loosen this heat sink. Now, this heat sink's pretty warm. That would be a good indicator that there's a problem. This heat sink should be cool to the touch. So if this is warm, you may want to kind of try to cool it off first. Make sure your fan's blowing at it. Then there's a certain process to removing all these parts, because the inner threaded barrel in here can really get stuck. And there's also a very important process. Just checking the video is still recording. It happens where it cuts out. Just make sure that you assemble and disassemble correctly. Otherwise, you can have further problems in the future. So, what we're going to do first is we need to get this nozzle tightened up against the interior threaded barrel. So, I'm going to kind of work in reverse here. If this is cool enough to touch, hopefully... Okay, that's not going to work that way. What you probably should get is a socket. This is a 9/32 inch, whatever 9/32 is in millimeters. I wish I knew. Probably around 6, 7. So hold the block, loosen the nozzle. So we're going to start by loosening, because we don't know if the nozzle is actually hitting the block or if it's hitting the threaded barrel. The next thing we're going to do is tighten the threaded barrel just a bit. And then we're going to re-tighten the nozzle. Now, this way we know that that nozzle is tightened up against the threaded barrel, and you can also see a little gap in there between the nozzle and the block. There should be a very small gap. Now, we should be able to pull out the heatsink, and the threaded barrel should stay locked against the nozzle, if that makes sense. And so we have success. Okay, I'm just going to let that kind of dangle. Still heated at 143 degrees. Make sure your thermistor's in. You do not want that thermistor coming out. And this would be an opportune time to clean any gunk. It's still warm. If the PLA is still kind of warm, it'll kind of act like a plastic kind of, well, obviously a plastic. It'll act kind of like a, you can kind of scrape it off a little easier, and it will stay together. Okay, so look in there and make sure there's no issues. Good to keep any debris out of the threads. Set that off to the side. Double check your thermistor's still in. Okay, next thing we're going to do is we're going to try a cold pull, and that's also going to clean the nozzle. Now, cold pull is where your temperature is kind of low. Okay. Should probably, it should be fine. Oh yeah, don't grab the block like that. You want to grab it on these two sides with some pliers. So you might be able to get a little flow coming out of this thing. 140 is just not hot enough, but that's what we're going for. We want this to be almost like elastic, so that when we pull this out, sometimes you can get gunk from inside of there to come out. So if little metal shavings have fallen inside, or you have dirt and debris inside, that will often take off any gunk. There's also something called Tallman cleaning. It's like a nylon filament stuff, and you can use it for like cleaning. Hopefully, though, do that 2 or 3 times, and you should get most of the gunk out of there. Maybe even turn the temperature down a little bit to 130. All right, so now we're going to continue with dismantling this, assuming that we may not have got the hot end completely cleaned. So your next step would be to break the nozzle free. At this point, yeah, 140 is not too hot. I mean, it's still pretty hot, but make sure that thermistor is still seated in there properly. You do not want that thermistor coming out this side or coming out the back. We've got a nozzle here. It's going to be relatively hot. Yeah, it's not too bad. This is pretty cold, so yeah, it's fine. You can attempt. That's yeah. You should be able to actually see through it. It's going to be a pretty small hole. You could at this point clean it, or you could at this point just replace it with a new nozzle. And there's one other area that we need to check, the threaded barrel here. And so let me give you a breakdown of two different threaded barrels. You have an all metal and you have a Teflon insert. The all metal one is for ABS, 245 temperatures and higher, nylon, stuff like that. The interior of this one has the Teflon tube. You can buy replacement inserts. It's not all the way through. It's only on the front half, about 10, 12, 15 millimeters of it. And it should come right to the edge, like that. On the heater block side, not on the heat sink, the heater block, hot end part. So this is for PLA and lower temp, lower resistance, because the Teflon has less coefficient of friction. Alright, so moving on. Let's get this guy out of here. Let's take the temp. Let's go ahead and turn the temperature off. Prepare. I think we can do a cool down. Yeah, cool down. So that'll cut the temperature. We're at 143. Now before it gets too cool, I would recommend, oh, those are kind of hot. Before it gets too cold, recommend making sure that you grab low on this. Make sure that barrel can come out. It might be kind of hot here. Yeah, a little warm. Okay, so wasn't too warm. You can look in there and make sure that there's no debris. I mean, you're gonna have some plastic. It's not. It just won't all come out. It's just part of a used hot end. This guy hopefully is somewhat cool. You can take a look at this. It's a little warm, not too bad though. And check that Teflon tube isn't damaged. And you also should be able to see straight through this thing. In fact, where's that filament? There it is. In fact, you should be able, a fresh piece of PLA should be able to go right through there. Yeah. So that's probably okay. If the barrel's good, then at that point, we can go ahead and do reassembly. So that's the next step, reassembly. Alright guys, it's Nate, Reach 3D Printers. We're ready for reassembly. This is super, super important that you do the order correctly on reassembly. The key ingredient for getting this to reassemble properly is that these two pieces are smashed together really well inside of that block. That's the most important part. If they're not, material is going to flow up. It's going to potentially cause jams. There's all kinds of issues that can create if these aren't smashed together. So what we have to do is take our temperature, prepare, preheat PLA, 1. So we're going to take this back up to 205. The very first step is to get the threaded barrel in, and then the nozzle. And if you're going to change to a new nozzle, now is the time to do it. If you want to change out the interior of this, if it looks damaged with new Teflon, again, now is the time. One thing that I hope that no one ever does, because I've done this and it's not good, is when you remove this to use any kind of pliers on that thread, because the thread damages, and then when it goes into the heat sink, it grinds the aluminum, and then you have bits of aluminum, and if they get into the filament, then that aluminum will clog your nozzle. Alright, we're at 158, close enough. Let's get moving on this. So I'm just going to start by, whoop, make sure you don't get yourself burned. I'm going to start by smoking. 213. Yeah, it heated up really fast because there's like no coolant in here. Again, make sure that your thermistor is seated in there. You want to make sure that your temperature readings are correct. And then thread this in, and you want to thread it in pretty far. Then the next step, and you got to be really careful here. Don't burn yourself. I do it by hand because it's easier to get it started that way. And then kind of just thread them in. Shouldn't be too hot yet up top. Okay, now see that gap there? That's good. We want a little bit of a gap between that nozzle and the block. There should be a little room there. So once we know that we got that, we're going to tighten these two together. This is so important that you tighten the nozzle to the threaded barrel. Okay. That nozzle and threaded barrel are smashed together really tight, and I know that because there's still a gap between the nozzle and the block. Crazy, crazy important. If you miss that, then all this will be for nothing. Alright, next step, throw on your heat sink, or actually that's a cool end. So it looks like my heater cartridge is a little loose. I was not planning to adjust that. See if I got a... No, that's too big. Of course, when you're looking for something, you can't find it. There you go. Alright, little tiny Allen wrench. The 1.5 millimeter Allen wrenches that are for the, I think for the belts, belt pulleys. Maybe. Yeah, I might want to snug that down a little. Yeah, there we go. Okay. This doesn't have to be sandwiched super hard, but you do want a little bit of a gap between the heat sink and the block. So the block kind of hovers in the middle. Then just kind of tighten it up a little. Doesn't have to be crazy tight. Alright, the next step is, this is assembled so we can... You can go ahead and do a cool down if you want, but since it's already hot, and we want to test it hot, then I'm just going to be really careful. Okay, make sure when you put your fan on, sticker faces the heatsink. Tighten that up. Notice I left the Z-cup, or the brass coupling, is not attached yet. Just get that somewhat tight. Proximity sensor is next. Almost there. Now this is like the worst case scenario kind of breakdown. Typically you don't have to go into those kind of depths. That's pretty extreme. Of course you also want to fix the problem that created it in the first place. But hopefully by checking those few areas, you'll either determine that the fan's backwards, the Teflon tube inside is messed up, or the nozzle has debris in it that won't clear out. There's only so many areas that can be a problem. Also, this can be a problem, but... So the next step that I do is when I get to here, I just want to verify. We are at 205. I want to verify that I can push some filament through this thing. And so, give a little push. And we do. We got filament coming through. So, I know that it's, for the most part, clear. If it's clear, then you're down to the very last steps of reassembly. If it's not clear, then you got to start back over and start dismantling the hot end again. Hi guys, we're back. Lost my video, but the next step, once this brass is tightened, you want to send this straight down through. Make sure it runs perfectly straight downward. May have to straighten out the filament, turn the large gear. You should start seeing it squeeze out, and then you know you've got it. That is the final step of the filament jam. Hopefully you guys got it cleared. Hopefully you found some stuff important, even if you don't have the Reach 3D printer. But if you do have the Reach 3D printer, thank you for supporting me, and have a good one. Thanks, guys.